So we're going to debug an electromechanical pinball machine. This one's a 1964 Bally skydivers, using the schematic diagram to figure out the fault. Now the fault today is this. If I just play it, you'll see it. So and you can see the game over light was on, went off for a short while, and now it's back on. The play number of bonus plays is back to 0. That's normal. But the main thing is you heard the score motor running, but not the balls being released. The balls are still there, and the fact that the balls are still there is probably what's causing the game over light to come back on, because it thinks all the balls have got back. We'll go into the game over circuitry later. It's quite an interesting thing. So going back to the schematic, the problem. A second. The problem centers around the ball release solenoid. And so it's these two rungs here, plus this lot. And I think the key thing is, okay, there's a game over there, so it does momentarily go off, so that makes contact. The reset relay, on the other hand, is a key part of this, because it powers the ball release solenoid directly. And the reset trip, it's a trip, is here, so we'll bring that over as well. So here it is. So what happens, you drop a coin and the start trip flips there and then back again, and it does that pretty quickly. That starts the score motor and a lot of other things. If the tilt relay is untilted, that's closed. Game over relay, well, you saw it went quiescent, so that was closed. The reset trip, again, if that is closed, the balls are released. But the reset trip comes straight from the power and through all these normally closed 1 point units showing a 0, which it does, and the 10 and the 100. The 1 CE score motor switch, which closes at 0, and then it's open. No, it's the other way around. But anyway, it's powered by the score motor, and it sort of goes on and off. But it's only on at 0 and off at 1, 2, 3, 4 steps 1, 2, 3, 4, 5. And then we have the reset trip, which stops this being powered, energized continuously, because once it's tripped, it's set. And the hypothesis is that this rung will power the reset trip quicker than this one, because this one has the start trip involved, and so it has to wait for that to come back. And the reset trip here, when it's set here, will open this switch and prevent the ball release solenoid coming out. So there is a race condition, and the reset trip can win if these are all set to 0. On the other hand, if any of these are non-zero and have to step through 2, 3, 4, 5, 6, 7, 8, 9, 0, that gives this circuit enough time to flip the start trip as you drop the coin and power the ball release solenoid. So moving one of these two onto 2 and trying it again, this happens. Game over goes out, this cranks around to 0, and you probably heard the balls drop, and the game's ready to play. So the moral of this story is, when you're debugging it, or when you're working on it, always set it back to a known position when you turn the power on and drop the coin again. And a known position is a non-zero score. And actually that's about it. I mean, you could manually reset all the relays, but that's done by the startup, so it's not really necessary. No, the score reels are the key. Don't try starting the machine when they're all zeros, because that's impossible to score anyway. You know, you can never play a game and get zero. So it's only when you're sort of fault finding that could ever happen. Okay.